Good morning, dear friends. This is a module which we are going to talk today is on application of remote sensing in geology, which is very important because researches are going on since long on geological studies, but the use of satellite data is a recent phenomena which was started little bit maybe couple of decades before. Before that it was the aerial photographs, and then from 1970s to 73 onwards we started using satellite data. Now let us talk about something, a couple of minutes on remote sensing. You must have also studied the remote sensing, what is remote sensing, in remote sensing module, fundamentals of remote sensing. Now remote sensing is nothing but is the art and science of acquiring information about the object phenomena which is not in contact with the instrument, that is a sensor. Now remote sensing can be classified into two classes, one in passive remote sensing and second is active remote sensing, based on the energy which is being used in the data acquisition. Now when we say passive remote sensing, that means we are using the sun's light. When we say the active remote sensing, the energy which is being used is the artificial source of energy, the energy which is there at the sensor which illuminates the ground terrain and captures the information. Whereas in passive remote sensing, we all know that is the sun's energy which illuminates the ground terrain and we capture the information. Now when we say the application of remote sensing in geology, there are various data set, data products of both active and passive remote sensing which is being used. Let us say satellite data which is being used for the remote sensing data in geology. One is called the passive remote sensing, and second is active remote sensing. Now this is I just now explained. Now if we move further, what we say that the satellite data which is being used is both active and passive for geological studies in geology. Now let us see the detail about the satellite data set which is being used for the geological studies. For that we can classify into four classes: the data which is optical data, which is sensed in the region somewhere between 0.4 to 0.7 micrometer. The second, the thermal satellite data, rather thermal infrared data, which is being used in the region somewhere between 0.3 to about 15 micrometer. Now the third is a microwave data, which is being sensed between somewhere between 0.3 to 3 nanometer nanometer to 3 meter. Now the fourth, that is hyperspectral data, which sends somewhere in between 0.4 to 2.5 micrometer. Now I was trying to give you a glimpse on the satellite data which is being used in geological studies, and these are the broad classification of the data which are sensed in different region, say optical 0.4 to 0.7 to hyperspectral from 0.4 to 0.5. Now, let us see the application and the use of these data set in geological studies. So, if we go in detail, what we can say that there are n number of application areas where these data sets are being used. Maybe we can talk each one in detail little bit. So, before going to that, if you see the figure 1 where we are talking about the active and passive remote sensing, how they are being used. So, friends, if you see the figure 1, which is very simple and basic, you must have also seen this kind of diagram and figure in fundamentals of remote sensing, where in the left side is shown as passive remote sensing, where the bottom left is the sun which illuminates the ground terrain as I said before, and the energy is reflected back to the sensor, and that kind of sensing we call as a passive. And the right side of the figure is a active remote sensing, where the rays from the satellite sensor is coming on the ground and it goes back. So, figure 1 is general about the different sensing technique. Now, let us talk about some of the applications. So, if we talk about the applications and the use, the application in use is n number. Say for example, study of lithology. Okay. The moment I say the lithology, it is nothing but, as a student of geology or geography, you all know lithology is nothing but is a study of characteristics of rocks. If you want to study different characteristics of rock, you have to understand the lithology. So, these data sets are very useful for understanding the lithology of any part of surface of the earth, whether small or large. It is also very useful for the study of geomorphology or geomorphology, which is nothing but is a shape and size and the form of a particular part of surface of the earth. Okay. Third is, we can say Geo Engineering, which talks about the study of landforms, study of hazards, maybe landslide, maybe volcanic eruptions, maybe flood, and many more. We also have the satellite data use and application in another field, that is Geo Environmental Studies, which talks about what are the environmental impact. If you want to understand, if you want to see, then we can use the satellite data in geoenvironmental studies. That is another broad discipline where we are using the satellite data sets. Now, let us talk about something little bit detailed on each one of the data sets before going to specific application areas, and in which I will be speaking on a little bit in detail what are different data sets, what are different data products that is being used for these kind of studies, that will give you more insight into the subject matter. So, friends, we are trying to see what are different data that is being used in the geology, and I have showed you that there are data right from optical to microwave to thermal 1, 2, 3 and 4 to hyperspectral. As I said mentioned before, optical takes data 0.4 to 0.7 micrometer, microwave take 1 nanometer to 1 meter, thermal takes 3 to 15 micrometer, and hyperspectral takes data from 0.4 to 2.5 micrometer. Now, I can tell you that with the advancement of sensor technology, the application of satellite data has increased manifold in geological studies. Before that, we were using data from aerial photograph. But as I said before, that with the starting of remote sensing from 1972 onwards, with the launch of NASA's program Landsat series of satellite, Landsat 1 in 1972. So, what we have started getting the optical data within this region and even beyond this in the infrared region. Now, what we have later on, as I said, that with the development of sensor technology, the scientists develop sensor which can use the microwave region of electromagnetic spectrum. Sensors are developed to sense, scan the earth surface feature in the thermal region of EMS. Sensors were further developed to use and to detect the earth surface feature in a hyperspectral region. I will speak little bit detail in this. So, what we have that if you take the, say for example, microwave data, and one very important data is the data of SAR, is a sensor that we call is a synthetic aperture radar data, which takes in situ measurement of the land surface feature, which is a new and important application of satellite data in remote sensing. Now, if we see the thermal data which sense somewhere in between 3 to 15 micrometer, what we have that the data which takes the land surface temperature, in a sense that it takes the if you take data of any particular part of surface of the earth, what we have that there is change in temperature when there is sunlight, what we have the land surface get heated, and then at night it gets cooled. The water bodies get heated less in the day compared to the land, and at night it gets cooler slowly, but the land gets cooler faster, because the law of thermal properties of any objects says that the hotter the body, cooler the body which gets hotter gets cooler quickly. So, rock surface hard surfaces get hotter in the daytime fast, in the night time it cool fast, but in the water bodies it gets hot in the day slowly, but in the night it gets cool slowly. So, if we compare the rock surface and water bodies, there is a big difference. So, if we take the thermal data, thermal infrared data of any particular part of surface of the earth, what we have the thermal inertia what we have is different on one particular part to another part. Say for example, if you take any geological studies and if you try to see any landform, so the weaker zones, the fault line and other areas which are weak have higher thermal inertia. That means in a common words, it have a weak zone, it is darker, and it is in the night it gives you a darker tone. You must have studied different visual interpretation techniques, where you must have studied the various image interpretation keys, where the tone was one of the important parameter for visual interpretation. So, the weak zones, suppose this is a landform, and if there is a weak zone, so on the weak zone you will find the darker tone. So, therefore, by using the thermal satellite data, we can get the land surface feature, where the weak zones, where the fault line, where are the other things which are there. So, by using the thermal data, we can use we can go for detecting the weak zones, where the chances of earthquake, folding, faulting will be more. Now, if we take the hyperspectral data, which is a very new data and very important. If you see this spectral region, it is very small, 0.4 to 2.5 micrometer, but what it does, it sends any particular part of surface of the earth into very fine, different, narrow, discrete bands, and therefore, the name says hyper. So, hyperspectral data, if you see the range is 0.4 to 2.5, but the bands are more than 200, sometimes 250, sometimes 350 or something like that. But whereas the data in optical, we have 3 band, 4 band, 3 to 4 band, or the best data what we are having, the 8 band data of word view. So what we have, especially this hyperspectral sensor has been designed in a such a way that it can be mainly used for geological studies. Why? Because if you want to detect even the minute and micro changes, for that you need to have a hyperspectral data, because we all know as a common man, layman, that even minute differences in the rock masses, in the minerals, what we have, the name changes and the things get changed. Say in a rock, if the silicate is 10%, it will be something else. In a rock, if silicate is 12% and 15% and 20%, it will be different. So therefore, in order to identify, I will show you in through diagrams that will give you more clear and better understanding and very clear understanding about hyperspectral data when I show you hyperspectral cubes. Okay, how we can separate even minor differences and changes. So hyperspectral data, as I said, that the best data and the important data and the sensor that what we are having, Hyperion, is a sensor of EO1, which is a NASA program. The Hyperion data which is being used for geological studies, they are having a spectral bands of more than 200, 245 to 250 or so. So what we have, we can use these data for fine and minute changes. Now, if you move further, as I said, the studies and the application of data in different geological field. The very first I said is the lithological studies, that is the characteristics of rocks. What are different types of rock? What is the, say for example, lineament, what is the fold, fault, and so and so. So through diagrams and some of the figures, I will try to show it in a better way. The second important issue, what I said, is the history of satellite data in geomorphological studies. I must tell you that it was a time when aerial photography started. The aerial photography was started using in geomorphological studies. Before that, we were using the survey winder topo sheets and maps. But survey winder topo sheet and maps are quite old. To have a recent data, so scientists and geologists started using the aerial photograph. But the problem of aerial photography was that to survey and to study geomorphology, you have to take a larger area. For the larger area, you need to have a n number of aerial photographs, and by using n number of photographs, you have to prepare the photo mosaic. So that was a big task. So therefore, in order to have a large area geomorphological studies, we started using the satellite data. So the satellite data, whether Indian satellite data from IRIS product or satellite data from Landsat products. In these two satellite data, we are having a sensor that is called multispectral scanner sensor. So what we have started using? We have started using a optical data for geomorphological studies. Then further later on, we started using the satellite data of Landsat, say for example, thematic satellite data, TM satellite data, ETM data, the data product of ETM plus, and so and so. Later on, we also started using the spot data, HRV data, high resolution videocon data. So these are some of the data products which are being used for geomorphological studies at a large scale, at a regional level, at the continent level, even in the country level. So geomorphological studies, people, those who are doing geomorphological studies, they are using the data products from various sensors. Even the Indian satellite data is quite good. Say for example, LIS3 data products, which is having a resolution of 23.5 meter. So these are the data products which are being used for geomorphological studies. Now let us come to the data say for example, which can be used for Geo Engineering. Geo Engineering. What I can say is that with the advancement of technology in different fields, with the increasing economic power of the people, with the faster mode of development, people have started doing various activities in different areas. So what we are having? We are having various impact on the landforms and others. So what we have? We need to see the impact of the land surface of different parts of the surface of the earth, and for that we are using the satellite data, and that can be classified into geoengineering. And one very fine example of geoengineering is that of the that is hazards. The moment I say hazards, there are a number of hazards, right from earthquake to landslide, debris flow, folding, faulting, sorry, not the folding, faulting and so and so. So what we have, because of faulting, landslides take place, the hazards. So if you want to do hazard analysis, you can take the data from any of these sensors depending on the area and the intent and purpose and magnitude, what magnitude and extent what you want to study. So hazard mapping is also very important, and that is can be classified into geoengineering. Now the second is, with the increasing human activities. With the increasing human activities means we are going to the areas which are prone to flood, in the floodplain and so and so. We are building the houses, industries and so and so. So we are enclosing the flood. So therefore, in order to assess and understand the the flood impact and the floods, we can use these satellite data for flood hazard mapping and assessment and so and so. So this is another very important hazard. Then the earthquake. Earthquake is a very frequent common phenomena which is taking place. Then we have the landslides. Then we have the tsunami. So all these areas, soil erosion, all these areas can be, all the issues which comes under the geology can be studied and can be understood by using these other satellite data. Since I have to let you know within half an hour, so I am giving you a glimpse of a very superficial glimpse of a clear understanding about the application of satellite data for various geological studies. In the geomorphic mapping, a very important, a very simple and common feature is that of the oxbow lake. What you see in the figure 7 is oxbow lake. That is when the river comes in the old stage in the plain areas, it started meandering. So during the process of meandering, what we have, the some portion of the river is separated out and it becomes a say for example is a lake. So if you see figure 7, the left side of this ring like appearance, it get detached in some period of time and it becomes a oxbow lake. The moment it gets separated, it becomes oxbow lake and the river start flowing straight. So figure 7 you see is nothing but is a simple subset of satellite image of optical data. Now friends, let us see another very important application of remote sensing in geology, and that is the application in mineral exploration. This mineral exploration, we all know that the mineral is a very important asset of a nation. So in order to understand and to know where all these minerals are and how much, so for that, as I said before, that with the advancement of sensor technology, there is another sensor that we call is a SWIR, short wave infrared region. In the SWIR band, there is a satellite that is called WorldView 3. So WorldView 3 satellite data in the SWIR region, which sends the earth surface feature into fine narrow bands, where we can discriminate, we can separate out, we can find out, we can see the different mineral deposition, where there are different minerals which are there in a part of surface of the earth. Figure 8 shows the exploration of mineral by using satellite data, and I mentioned in my discussion that the most important recent satellite data, that is World View 1, World View 2 and 3. So, in the World View 3 there is sensor that is called the SWIR, short wave infrared. So, if you see this is the extracted information that is being represented in figure 8. If you see the bottom left part of this image which has been classified, what you see that has been zoomed in on the right side of it. If you see the index, then we have iolonite, then calcite and then silica and so and so. So, what we see that these the minerals and rocks can be separated out if we use the data which is being scanned and which is sent in the more spectral bands. So, this is one example that has been given in this module, that is short wave infrared data that is being used for separating out. So, this is another very important application, that is a mineral exploration. And another very important, probably the last important application that I can say is that of the I have already mentioned is a Geo Environmental Studies. And that is very interesting in the sense that within this there is various broad studies which comes under, say for example, with the various activities what is happening, the groundwater is being degraded and groundwater is being changing, groundwater depletion and so and so. So, what is happening? What impact is going to have on the land surfaces with the changing the groundwater structure, that kind of studies by the satellite data. There is another very important study is that of the landslides and soil erosion and deforestation. What impact is going to have with the changing the soil and deforestation on a particular part of the surface of the earth. There is another very important application and study that with the various industrial activities the industrial smokes and plumes are coming up. So, what impact is going to have on the particular part of surface of the earth, that can also be studied, that can be classified into the area that we call this Geo Environmental Studies. What land is being changed with the open cast mining. In the mining areas, especially in the Bihar, Bengal and Odisha, Chhattisgarh, with the mining activities, the whole of the land form, whole of the land use is being changed. What impact is going to have on the land use change with the mining? If we want to study, obviously we need to take the satellite data. The satellite data detail I have explained you in detail. So, all these areas of concern and studies comes under the Geo Engineering, Geo Environmental Studies, which is a sub part of the Geological Studies. So, friends, there are n number of other studies that you can go through the module which has been written already and can get a detailed glimpse of it. Now, friends, if you see figure 5, which is a part of structural mapping, as I told you before, we can map folds, faults, attitude of the bed and so and so. The moment I say attitude of the bed, that consists of depth and strike slip and depth slip, strike slip fault and depth slip fault. So, figure 5 shows the strike slip fault on aerial photograph, which is again a part of United States. So, even on the satellite data, what we can do is we can do a mapping of structural geology and geomorphology through remote sensing, where strike slips and the fault line and depth slip can be commonly noticed and can be mapped. Figure 6 shows clearly the mapping of linear features, and I have mentioned in my discussion that one of the most important linear feature is the lineament, that is a faulting. We can also see the joints, we can also see the fractures, we can also see the faults. So, this figure 6 shows clearly different components of the linear feature on different images, right from RGB FCC data to SRTM data, below SRTM data and so and so. So, friends, today we have tried to understand the use of remote sensing in geology. In that, I have given you a glimpse of different satellite data products. I have also explained you different regions, different bandwidth and different bands which is being used. that is effectively being used in the geological studies. I have also tried to give you a glimpse of different specific areas where the satellite data is being used that can come into geology. Say for example, I have talked about geomorphology, I have talked about lithological studies, I have talked about geo engineering, I have talked about geo environmental studies, and so and so. So, the application of satellite data in geological studies is enormous, which you can say countless, but some of the important studies that is going on and that can be used, I have tried to give you a glimpse, and especially I have tried to focus on the satellite data, especially the thermal satellite data and the hyperspectral data, which is very important and new one, because the hyperspectral sensor is especially, as I told you before, is designed and developed for the geological studies, for mineral exploration, mineral discrimination, rock type discrimination, and so and so. So, I do hope that you could have understood, and if you have any doubt and if further issues, you can go through the module and have a better understanding and clarity. Thank you so much for your attention.